Let us start with the hydrogen molecule, which is formed by the combination of two hydrogen atoms. You know that a hydrogen atom has just one electron, and it is placed in the 1s orbital. So, a hydrogen molecule will have two electrons that are present in the sigma 1s molecular orbital. The electronic configuration of a hydrogen molecule is sigma 1s2. Let us calculate the bond order of hydrogen molecule. As the number of electrons present in the bonding orbital is 2, and as no electrons are present in antibonding orbitals, the bond order is equal to 2 minus 0 divided by 2, which is equal to 1. This shows that there exists a single covalent bond between two hydrogen atoms. The hydrogen molecule is diamagnetic in nature, as no unpaired electrons are present in its molecular orbitals. Now let us discuss the bonding in a helium molecule. A helium atom has two electrons in its 1s orbital. Hence, the number of electrons in a helium molecule is equal to 4. These electrons occupy the sigma 1s and sigma star 1s molecular orbitals. Hence, the electronic configuration of a helium molecule is sigma 1s2, sigma star 1s2. Now, from the electronic configuration of helium, we can easily derive the bond order of the molecule. As the number of electrons present in both the bonding orbitals and antibonding orbitals is 2, the bond order is equal to 2 minus 2 divided by 2, which is equal to 0. This proves that a helium molecule is unstable and therefore does not exist. Similarly, beryllium molecule with an electronic configuration of sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and a bond order of 0 is considered to be non-existent. Now let's see the bonding in a lithium molecule. A lithium atom has an electronic configuration of 1s2 2s1. Thus, there are 6 electrons in a lithium molecule. The electronic configuration of a lithium molecule is sigma 1s2, sigma star 1s2, sigma 2s2. This configuration is also written as kk sigma 2s2, where kk represents the closed K-shell structure sigma 1s2, sigma star 1s2. As lithium has 4 electrons in its bonding molecular orbital and 2 electrons in the antibonding molecular orbital, the bond order of lithium is calculated to be half of 4 minus 2, which is equal to 1. From the bond order, it is clear that lithium is a stable molecule, and as no unpaired electron is present in its molecular orbitals, it is diamagnetic in nature. This diamagnetic lithium molecule is found to exist in the vapor state. Now, we'll see the bonding in another diatomic molecule, carbon. An atom of carbon has an electronic configuration of 1s2, 2s2, 2p2, which makes a total of 12 electrons in a carbon molecule. The electronic configuration of a carbon molecule is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2. which can also be written as Kk sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2. The bond order of carbon can therefore be calculated as half of 8 minus 4, which equals to 2. In a carbon molecule, the two atoms have a double bond between them. Both the bonds are pi bonds due to the presence of 4 electrons in 2 pi molecular orbitals. A carbon molecule is dimagnetic, as no unpaired electron is present in its molecular orbitals. It is found to exist in the vapor phase. Now let's look at the bonding in an oxygen molecule. Two oxygen atoms combine to form an oxygen molecule. The electronic configuration of an atom of oxygen is 1s2, 2s2, 2p4, and hence there are 16 electrons in a molecule of oxygen. The electronic configuration of oxygen molecule is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1, which can also be written as Kk sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1. The electronic configuration of oxygen molecule is such that there are 10 electrons in the bonding molecular orbitals and 6 in the anti-bonding molecular orbitals. Thus, the bond order of oxygen can be calculated as half of 10 minus 6, which is equal to 2. Hence, the oxygen atoms in oxygen molecule are held by a double bond. It has been proved experimentally that it is paramagnetic in nature. This is due to the presence of 2 unpaired electrons in its molecular orbitals. Similarly, the electronic configurations of other homonuclear molecules such as boron, nitrogen, fluorine and neon are shown here, from which bond order and magnetic property can be calculated, as given in this table.